As far as I'm concerned, as long as that same respect and recognition is not shown toward every one of our people in this country, it doesn't exist for me. And during the few moments that we have left, we want to have just an off-the-cuff chat between you and me. Us. We want to talk right down to earth in a language that everybody here can easily understand.
In a pandemic, in a panoramic, in a Panasonic, and all the other ingenious way Black Twitter had decided to call what we're going through right now. Before I bring in my guest, I do want to kind of say our thoughts and prayers with all those who have lost people to this terrible, terrible disease, COVID-19, and our thoughts and prayers with all those who are still suffering with it right now. Yes, unfortunately, I do say unfortunately, we are living in an age of disinformation, misinformation, and people have said everything under the sun regarding COVID. Many of the times it comes from people who are not actually experts. So I found it incumbent upon myself to bring in an expert, Dr. Azza Gadir, to kind of talk all things COVID. So thanks for coming on.
Thank you for having me.
An absolute pleasure, absolute pleasure. First things first, in the most simplest terms, what is COVID-19 and is it just an extreme flu?
So COVID-19 is coronavirus disease 19, and it's caused by a virus, a coronavirus called SARS-CoV-2. And so not everybody who's infected with the virus actually develops symptoms, which is what the disease is. And those symptoms usually appear around 2 to 14 days after you're exposed to the virus. And the types of symptoms that you get are things like fever or chills, cough, shortness of breath, fatigue, muscle or body aches, but you can also get, in some people, severe cases which can result in organ damage or even death.
Wow. So people say it's just an extreme flu. What is your response to that?
Yeah, so the response to that is it's not. I would say that there are lots of differences. First of all, it's a different virus. Influenza is a completely different virus and works a little bit differently. I would say that you can just look at the rates of people that have died from flu, particularly in the last year, compared to those that have been infected with SARS-CoV-2 to really see the difference. But I think the most important thing to remember is that the reason why we've been so panicky with this virus and with this disease is because you can get it, a number of people get long-term symptoms. So what happens is that even months after they clear the virus, so even after their immune system gets rid of it and they start to recover, there's a percentage of people that will still have symptoms that continue and can continue for months. And this has actually now been defined as a syndrome called long COVID. And these are people who are not infectious, so they don't have active virus, but they still have symptoms as a result of being sick. And so I would say that that's the main difference between the two. With the flu, you don't get people who clear the virus and then continue to have symptoms months after. But this is what we're seeing with this disease, which is why it's been a little bit more panicky.
I got you. So in short term, how are people killed from this virus?
Yeah, so what happens is that you get infected with the virus, right? You breathe it in. And then what happens is that your immune system, so you have to think of viruses, they're not alive. And what that means is that they need your own cells or they use cells to make more of themselves. So what happens is that when you're infected with the virus, you breathe it in. And then it goes to these receptors that you have in your airways, and it's like a lock and key. And these receptors in the airway, basically the virus uses them to get inside of the cell. And once the virus gets inside of the cell, it uses the cell's own kind of machinery, which we can get into a little bit more detail later. But it uses the cell's own machinery in order to make more virus particles. And then that cell will release the virus particles and they will go on to infect other cells. And then what happens is that the immune system starts to notice there's something here and it's not normal and I need to start clearing it. And what you get in people who develop COVID-19, who get symptoms, it's their immune system trying to clear the virus and trying to fight it. And in some cases, your early immune responses get a little bit overwhelmed. So they start to ask more serious type members of your immune system, which we call the adaptive immune response. Like, can you guys come and help us out here? And that adaptive response comes with think of it like it becomes a war, like the battle becomes a war. Your immune system is trying to clear this virus. And these viruses have evolved different ways in order to they've worked out ways to trick our immune system or hide in ways that our immune system sometimes can't recognize. So what you get in people who get the disease but clear the disease, right, who recover, their immune
Yeah.
system has effectively cleared the virus, right? Or gotten rid of the virus that it can see. But in people who go on to get severe COVID-19 and then even go on to die, what happens is that their immune system starts to get really overwhelmed. And in people that end up dying, they end up developing pneumonia, for example, which is when
Okay.
your own immune cells start to get like really overwhelmed getting the virus, and then it just becomes this kind of complicated situation where your immune system is trying to clear the virus, but it's also trying to control its own responses. And then basically
Wow.
that overreaction ends up in pneumonia, and then in people who end up dying, their body just their immune system doesn't recover, right? It can't get a foothold back, and that's why you get that. And so, yes, the reason why people who die of COVID-19 die is because at some point it goes from their immune system fighting the virus or trying to clear it to also this like inflammation that you have where the immune system is trying to clear itself. I hope that was
Thank
clear.
you. No, that was really clear. So I learned a lot in that. So thank you so much for that. Thank you so much for that. So okay, so then in moving on, people often say there's many doctors out there who are
Mm.
also saying do not take the vaccine. There are many doctors out there who are saying that this is, they've brought into some maybe what people will dub as conspiracy theories. So you as a health professional, you as someone who's involved in this field, how do we as the public choose from doctors when what they say in public is sometimes contradictory?
Yeah. So I think it's important to keep in mind that the scientific field has a lot of specialists, right? Like you
Yeah.
have virologists, immunologists, then you have clinicians who are the people who like see the patients. So while you get taught, like in general in science, you'll have similar basic skills, such as the scientific method. So things like how to analyze data, how to read research, how to try to not have bias, jade your analysis of data, for example. All of these things you can find in common amongst scientists. But at the end of the day, the human body is incredibly complicated. And I think the example that I always give is that the human body is complicated because if it wasn't, then these viruses and bacteria would have won, right? A long time
Yeah.
ago. Like they would have
Yeah.
been able to like cause a lot of disease, and we wouldn't have ever been able to work out how to survive. But so for example, while a clinician is excellent to help you better understand how to diagnose and treat a disease, if you're trying to
Hmm.
understand the workings of the virus, then it's probably better to look more towards virologists. Or if you're trying to understand the immune system or how the immune system is responding to the virus, it's probably better to ask an immunologist because they'll understand inflammation and what that means. And so I think it's important, like your question was how do you identify experts? And I think it's important to define what an expert is, because a lot of people think
Hmm.
an expert is someone who, thinks a lot of themselves and thinks they know everything. But I think that the very basic definition of an expert is someone who understands the context, right? It's somebody who's been
Yes.
working in something for so long that they would be able to say to you, these results in the context of what we know previously, this is what they mean. And also, like, you're missing these things that are like little tricks that we've worked out over the years. And so that's why
Mm.
it's important to keep in mind that there are while some doctors might come out and say, don't take the vaccine, I would respond to them and say, why not? Right. And
Okay.
if their response is a scientific one that makes sense, then that's very different. But I will say that my experience has been that I to date haven't met a research scientist who understands the technology and says no to the vaccine. It's
Okay.
wrapped up in a greater distrust, which I think is completely valid, and we can touch on if you'd like. But I think that the healthcare system has had like a one size fits all approach for a while. And that's why people sometimes have felt a little lonely when they have a disease that hasn't been easy to diagnose and they felt ostracized by doctors. And so I think that given that like it's been difficult to like not have a one size fits all approach in the past,
Yeah.
I think this is where a lot of this distrust does come from. But I just, the one thing that I think is important is that it is everybody's right to decide if they want to take this vaccine or not, right? But it's just
Yes.
important to make sure that you're doing it because you understand how they work and you have real valid information, as opposed to not wanting to take it because someone's told you something that's actually not factually correct.
Yes, and so I hear that a lot of times from my friends and from people that I know. They'll say things like, "Okay, well, what do we do? We have this doctor," and I do recognize it's wrapped up in a greater kind of conspiracy because they say, "Look, they even struck him off for speaking the truth. He uncovered their evil plans." But I do
Mm.
also retort. I also retort with that. I think it's very far fetched, personally, to get all these doctors to come together and conspire from all over the world for I do
Yeah.
think so. I think it's quite
Yeah, I think that's a completely reasonable response.
yeah. So next question is then, do doctors get paid for writing COVID on the death certificates of people who die of COVID?
No, and actually, I don't know. I haven't seen any evidence to support that because I would like to understand who would be paying them, right? I mean, to answer your question seriously, this is something that I've talked about with a lot of my friends worldwide, right? In the US, in the UK, or in the Middle East that are working as doctors. And I think anybody who knows a doctor who's had to work on the front line during COVID-19
Yeah.
knows that they're absolutely exhausted, that they're
Yes.
overworked, that they would rather, they would rather not have people not come in with this virus or this disease. And if anything, I think the data is showing that governments and hospitals are losing money because of COVID-19, right?
Yes.
Because they still owe a standard of care, but like it's you can't ask people if they can pay for that treatment, right? So I think that all of the data actually shows the opposite, that governments and hospitals are losing money over this, as opposed to being incentivized to write it on a death certificate.
Thank you. Thank you. And then someone will then say, is the measures we're taking in terms of lockdowns and mandatory masks in proportion to the actual threat that this virus poses?
Yeah, I've heard this one a little bit as well. And I think that it's a good question, right? Because these
Yeah.
lockdowns do seem extreme and they're hard, they're not easy. But I think there's two ways to answer this question. There's the science, but there's also the economic argument. Okay. And to answer the latter first, I think even economists have come out and they've said that lockdown is objectively the right thing. Okay. Because
Yeah.
the virus is the enemy here. And if you look at countries that, or even states in the US that didn't lock down, you can see the impacts of that on their economy. I mean, I can give you Sweden as an example. Sweden
Yeah.
did end up implementing some measures, but we know that compared to neighboring countries, they had less measures in place. And actually, Sweden's GDP was lower than neighboring countries. And also, the rate of deaths and the number of people they lost were way higher. So, like, that's an
Mhm.
example that says that economic argument doesn't really make sense. But from a scientific perspective, we keep having to lock down because we keep failing to do all the other things. And I think that people
Yep.
keep forgetting that. So we have, let's mandate masks. People don't want to wear masks. Okay. So then the virus
Yep.
is still, or they don't want to wear masks properly. So then it's like, all right, let's try and do a stay at home where we limit movement of people. And then people don't want to do that. Right. And so then it
Yep.
was, let's try and increase ventilation, and a lot of people didn't really understand the science. And that was a hard one.
Yes.
So my point being is that lockdowns are a last resort. And to me personally, if I want to get a jab in, they're a last resort because of weak leadership. Okay. Because if you look at
Okay.
countries that had stronger leadership, and
Yep.
countries that have managed to actually control the spread of
Control.
this
Yep.
virus, they didn't need to repeatedly continue to lock down, right?
It
They
was a
did it
zero
for
COVID strategy.
exactly,
Yeah.
exactly.
Okay, so
So
let's for my listeners, and I'm gonna kind of implore you to explain this in this most simplest way if we can, yeah. So the question is the government trying to control us by producing a fake virus? Will it be possible to fake? So let's talk about what is a virus first and foremost. I know you explained before, but let's do it again, even more simple this time. What is a virus? Where did they come from? What happens when they enter the body, etc., etc.?
yes. So a virus is a microorganism. So these are like tiny infectious things, right? That only
Yep.
replicate, I think, as I mentioned before, in living cells. Okay. And
Hmm.
so viruses are everywhere, by the way. So I will tell you that on our body, inside and on our body, all over, I'm sure you've heard this word microbiome. We, we
Yes.
have we have this thing called a microbiome, right? So we have these bacteria and viruses and fungi that live all over our body. Okay, and they're
Thanks for
living
that.
there passively. And they're like, it's really interesting because they're actually our friends a little bit. Like, these are things
Okay.
that have been sitting on our bodies. You can inherit them. They actually communicate with your immune system to keep you happy and healthy. And so
Okay.
viruses are something that aren't always bad. Like, the majority of them are actually, they're fine. They sit in our bodies and they don't do very much, or you'll find them out in the environment. But on occasion, you'll have a virus that actually is able to cause disease. And what happened with this virus is that, I'll answer the question that you had about it being faked, is that, don't
Yes.
forget that this is SARS-CoV-2, right? So
Yes.
we had a SARS-CoV-1, but a
Yes.
lot of people think that they were closely related, and you can think of them more like cousins. Okay. So
Okay.
so we've seen them evolve. And if you think of the way viruses work, viruses are constantly mutating because they again use the cell itself to make more of themselves. And they
Okay.
mutate, and the fact that they mutate is just the nature of who they are. But those mutations typically don't always result in the virus behaving differently. They're just like random mutations
Okay.
that happen, right? And so that's where you'll hear the word variants a lot. Variants are just like different kind of versions of the same virus. And they don't necessarily mean that the function, the way that virus behaves, has been altered dramatically. Okay. So,
Okay.
in answer to the question, the reason why it would be difficult to fake is because these viruses they're complex, and we also have been monitoring them, right? Like we've had virology labs and research labs that have been monitoring them out in the field and out in the world to see how they evolve and how they work. And so
Okay.
SARS-CoV-2 wasn't completely like its genome wasn't completely random. It was very clear that it had evolved similarly from SARS-CoV-1. But what happened was that it was a very unfortunate set of circumstances that led to this virus jumping from either a bat or a pangolin. It jumped into
Okay.
a human and then it caused disease. And then, quick thing I'll mention here is that this has happened before in the past. Like viruses will sit in like animal reservoirs and they're fine, but then something will happen. They'll jump into humans, and sometimes they won't do anything, but sometimes it's unfortunate enough that this virus has now worked out how to evade the immune system and cause disease. Okay. And so I mention
On
all of
that
that.
point, sorry, on
Yes.
that point, just to check,
Yes.
evade the immune system. What does that mean?
Yeah, so if you think of, I think a lot of people don't understand how the immune system works. And so
Yes.
your immune system is the point of it is for it to prevent you from getting sick. So
Yes.
what happens is that you have your immune system, you start building it from when you're born. And so children are typically, or babies are born with really good innate responses. So
Okay.
they're really good at non-specifically being able to clear infections. But there is
Okay.
a second part of your immune system, which is really important. And I mentioned it earlier. And so what happens, and I'll try to break this down, is that if you get infected with something, you have,
Hmm.
again, like these immune cells that are non-specific. They're just walking past, they see this thing, and they're like, I need to remove this from the body. This is foreign. So they start
Hmm.
to fight it. Okay. And this process actually happens, I would tell you, thousands and millions of times in your lifetime, actually, millions of times, that your innate immune system will effectively clear something you breathe in, comes in through your eyes, comes in through any other orifice. They clear it, they get rid of it. And most of the time, you do not even notice, you don't get symptoms. But on
Okay.
occasion, you get this virus or a virus like SARS-CoV-2 that will, your innate immune system will try to fight it, and it will say, like, hang on, this is a lot. I don't know how to get rid of this. So then
Hmm.
what it does is that it grabs a little bit of that infection and it runs into your lymph nodes and it says to your adaptive immune response, hey guys, this is something that's entered the body. We can't clear it. Can you guys start training? And so what you
Wow.
get is that you get this other compartment of the immune system, T cells and B cells, that will start to very specifically train themselves to only clear the thing that they've seen. And it shows you how
Okay.
specific the immune system is, right? And so then what happens is that after they work out how to fight that thing, they rush to the site and they clear, it's very specific. They clear every cell that's infected with the thing. They don't even hit cells that are uninfected nearby. And
Wow.
they clear any virus that they see floating around. And that's the second part of your immune response. And the reason why that stage of your immune response is so important is because that's the stage that if you activate that compartment, your body will remember it. So that's when you get immune memory.
Oh.
Yes. So then understanding that sequence of events helps you understand why the only way your immune system the only way you can prevent yourself from getting a virus like SARS-CoV-2 is for your immune system to see it. The only way it can see it is if either you go out and you get SARS-CoV-2 naturally, which we know is unpredictable. You can't control the amount of virus that you breathe in. You can't
Hmm.
control how sick you're going to get, like your genetics, for example. Or the other way that you can show your immune system that virus is with a vaccine. And that is essentially what a vaccine is. It's a way of showing your immune system something in a safe way so that if it ever were to see it again, it's already got these cells ready for it to clear it.
Okay, so before we come on to all things vaccine, if someone has had it before, do they have the antibodies enough forever after that point then?
Yeah, this is probably like the most important question we should all be asking, right? How long does
Yeah.
immune memory last? So the thing about natural infection is, again, it's unpredictable. So if you get exposed to SARS-CoV-2 super mildly, we don't know whether you can, like, if your innate immune response, for example, clears it, we don't know whether you will always necessarily mount enough antibody responses, right, with natural
Okay.
infection. So when you're infected naturally, there are three groups that you can fall into. You do have the majority of people who mount memory responses, right?
Okay.
But who get antibodies, and that's how we measure up memory responses. We measure them with antibodies. But you also get a subset of people who mount responses, but then seem to lose them after a few months, which means that
Okay.
you would think that maybe that would make them more open to infection. But you also get a third group of people who don't mount memory responses to begin with. And so again, because natural infection is so unpredictable, that's why when people say, oh, they're pushing a vaccine, it's not that we're pushing one. It's a risk assessment, right? It's a balance. And clearly
Okay.
it's safer for you to see the virus in like a controlled setting and one aspect of the virus that your immune system remembers anyway, as opposed to overloading your immune system with all parts of the virus.
I got you. Got you. Okay, thanks for that. Your description, that you need to be a narrator for like a immune film or something, immune cartoon. That was really epic. That was really epic.
Sign me up.
Uh, Before we go into vaccine, last question before the vaccine is: can the numbers be faked? People saying, "Oh, they're faking the numbers." Can the numbers? I don't know how it works in hospital. Can they be faked?
Yeah, I mean, I don't think I've said this yet because to be clear, I have a PhD in immunology. I'm not an MD. So
Okay.
I'm not on the front line. Like I wasn't seeing patients. Like that's not my specialty. But I think whenever I hear this question, I just think of like ICU capacity. Like we know that the ICU is full, right? We know these
Yes.
hospitals are overwhelmed. And like literally talk to any doctor that you know, and they'll tell you that they've been working overtime, they've been separated from their families, like this isn't something that's been easy. And so I would say just reasonable sense, looking at all of that data, like what numbers are we faking? And I think it's people are dying, like people are losing family members, people are dying. So
Yep.
clearly this is a problem, right? So, but I would say that the problem is, and the thing that's really sad is that because of how infectious SARS-CoV-2 is, right? Most people who've lost someone to this virus will say to you that you're not allowed to hang around and hold their hand in the hospital room, that
Yeah.
they're separated away because of the risk of infection. And I think that this has actually been a really big problem because people can't see, right? Like people who haven't been directly impacted
Yes.
by
Yeah.
somebody who's died of it can't see for themselves what's going in the hospital rooms, because you can't have cameras willy-nilly in a hospital room with a virus that's
Yes.
this infectious. I think that that's what's causing like a lack of empathy a little bit, where it's hard for people to empathize and see that this virus is a big deal. So
Yes. Yeah.
but in answer to your question, I'm not going to say absolutely no, numbers can never be faked, but it's just being reasonable here and looking at some of the objective data that we have at this point. People have
Yes.
died, right? People have
Mhm.
gotten really sick. People are suffering, and that is very clear. And I think just looking at data like ICU capacity or the number of people that are being turned away for a hospital bed for other diseases because this virus is overwhelming our hospital system, I think that's all we need to keep an eye on, really.
Thank you, thank you. And then scientific method wise, then, so you're someone who's an expert in a field. So again, I know we've touched on it before, but I just want to kind of unpack it a bit more. So the thing of you have doctors who push certain things. How does scientific community work? Is it like the majority is right? Is that how it works? Or you have a hypothesis, you test it, and if you're right, you get expert status in this thing. Like, how does it work?
Yeah. So I mean, scientists have egos and people forget that, right? Meaning
Yeah,
that if you take a field like my specialty was autoimmune disease, like my PhD was in lupus
yeah,
disease in particular. So think of it like you have a handful of labs that are like at the forefront of publishing like research in this field, who have like the most cutting edge work. And so,
yes,
I wish science was more collaborative in general. And most people would say that, scientists are, you have a hypothesis, you test that hypothesis. If it's a brand new hypothesis, you have to go through more to really prove to the field that what you
okay,
have fits with what has been shown previously. And then what happens next is that you write a paper and you get peer reviewed. So this goes
okay,
out to all of your competitors. Like think of it like, I don't know, like every time a rapper releases a track, they have to send it out to to other, like his main, like people he has beef with, to ask them what they think
it's
of the
up.
rap, right? Yeah, exactly. But it's the same thing. It's like you're sending out your research to other people who actually have more incentive to tear your work apart. And that's what the peer review research process is
Okay,
where it goes to your competitors. They come back with critique. why did you do this? How did you do this? I need more. I need more. I don't believe the message. I need more research to show that. Then you go back and forth, sometimes for years, by the way, before
Okay.
finally you have a final version of the research that your peers are happy with, that like it fits in with other stuff. So the short answer to your question is that science generally is not super collaborative,
Okay.
which means that like good research when it comes out has been vetted. But with
Okay.
COVID-19, when this virus emerged last January, this virus, there has never been another virus that has been scrutinized as much. There was so much
Wow.
worldwide collaboration. There was transparency. I mean, at this point, we have, I know you don't want to talk about vaccines yet, but we have vaccine companies that are making vaccines for their competitors just to speed up the process because everyone is just really wants to get rid of this virus and help come to a solution, right?
Wow.
So I would say that generally the scientific community is not super collaborative. However, in this example, it has been, and it has been way more transparent than we've ever seen, which is what part of the reason why we've managed to move the research so quickly.
Thank you. And that's a beautiful segue to how has the vaccine been produced so quickly?
So, what I just mentioned, which was like there was an urgent response, the entire scientific community came together. I'm going to
Okay.
start by saying last January, when this virus first emerged, at the beginning of January, China put the genome sequence online for the virus, right? So they put a bunch of
Okay.
letters online and they were like, we've sequenced it. This is what it is. And when they put that code online, it allowed research labs worldwide to start their research, right? They took the sequence, they made that into like protein in some cases, like to start to analyze and start to work out what is going on here because it was moving so quickly.
I'm
And
gonna sound really stupid, but what's a
yeah.
sequence?
Oh, sequence. So when you get your like genetic sequence, right? And what happens is that you'll send a bit of your blood. This
Okay.
is your very specific signature, so it's your genes, right, that code for who you
Okay.
are. And it's like it would be like pages of code, and it's specific to each person. So like for example, if you find DNA at a crime scene, you can use that DNA to then sequence it and find out who it
Okay.
was that was at the crime scene. It's
Like
it's that's
like a matrix scene with all numbers.
Yeah, it's just numbers, yeah. And
Yeah.
so what you have is that the sequence to a virus is the identity of it. And so when
Yes.
the genetic sequence, the genes for what SARS-CoV-2 was sequenced by China and then put online, that was the moment that then like every research lab worldwide decided, all right, we need to start investigating this virus because it's killing or it's moving very quickly. And that was the
Yes.
concern at the beginning, was the speed of it. So to answer your question, was the vaccine rushed? So many labs pivoted their research, which allowed for worldwide collaboration. I'll tell you that both of two labs that I was previously in that were more
Yes.
focused on things like food allergy or autoimmunity pivoted and started working on COVID. So like, and
Oh,
people were working day, they were working night, researchers were working weekends. So that meant that we managed to work quickly in terms of understanding the initial stuff around this virus, right?
mhm.
Second of all, the fact that there was widespread transmission meant that the clinical trials could move faster, meaning that typically, if I wanted to run a clinical trial on a disease like, say, diarrhea, I wanted to see if I can test a treatment in diarrhea. I need to go and find people who are around the same age, for example, who have the exact same type of diarrhea for me to recruit them. Okay.
Okay.
But in this case, and recruitment can take a long time with clinical trials because going to find the people, interviewing them, working out if they're the right person. In this case, we could move way quicker because there were so many people that had SARS-CoV-2 and COVID-19 that it meant that recruiting for the trial just moved faster. The third reason why
Mm.
we managed to move quickly is because there was a lot of money in public and private funding. And typically with clinical trials, you have phase one, which is when you look at safety. Phase two is when you add a placebo group and you look at whether the thing works. And then you
Okay.
have phase three, which is when you look at whether the thing works in like multiple sites to make sure that regardless of things like environment, that the thing will work the same way. And so the reason why I mention that is that what you have is when you typically have treatments, you go into phase one. If your
Mhm.
product is safe, you take that data to show it to investors or to like to investors to say, give me more money so I can now move into phase two to show whether this thing actually works. And then
Mhm.
after phase two finishes, you take that data to raise more money to go into phase three. There was no fundraising required in this process, which is why we managed to just stagger phase one, phase two, phase three
Okay.
for the clinical trials because they didn't need to go and sit in meetings and work out where to get the money. The other reason why we've managed to move quickly is because the mRNA technology. So for the two vaccines that have been authorized in the US,
Mm-hmm.
Moderna and Pfizer, this mRNA technology has actually been around for 3 decades. And so we already had a backbone to the technology. We didn't start from scratch last January. And while these are like some of the first mRNA vaccines to be approved for emergency use, they're not the first to go through the clinical trial process. And in fact,
Okay.
we put this mRNA technology in people as early as 2017. So we have some data already from like how this
Oh,
technology works.
I'm gonna have to ask you to unpack what does mRNA do, or what is it?
Yes, messenger RNA. We can unpack it. I'll just quickly to finish again, just
Yes.
like to finish why we managed to move so fast is it's been around for years, and then the last reason why we've managed to work quickly is that government is incredibly bureaucratic. The clinical trial
Mm-hmm.
process is incredibly bureaucratic, meaning that when you want to develop a drug and you want to put it through the clinical trial process, you have to meet with regulatory bodies in the government frequently. You have to show them all of the data. These are sit down meetings sometimes that you have to wait for a fact to be called to like come in. And so just to say that like instead of waiting months for a meeting in order to do the next stage, all of this
Yes.
stuff was fast track.
Okay.
So mRNA stands for messenger RNA, and this is the technology that was used to produce the Pfizer and the Moderna vaccines. And so
Okay.
to help explain how these vaccines are working, because earlier I helped explain how SARS-CoV-2 infects the body and causes
Yes.
COVID-19, right? So what scientists did was that they worked out what part of the SARS-CoV-2 virus the immune system remembers without
Mhm.
and tried to remove the other parts of the virus that can cause the disease. Because again,
Okay.
we want a vaccine to be safe. We want it to show your immune system something so it can start mounting responses without you getting symptoms. And so
Yes.
the way that the mRNA technology works is that when the sequence was made available by China last January, and then that sequence was taken and it was used to make something called messenger RNA. And what messenger RNA is, it's a recipe, right? It's a recipe
Okay.
for the cell that tells the cell how to make something. So to take a step back, when you get injected with the mRNA vaccine, the
Yeah.
only active ingredient in that vaccine is the mRNA, which codes for just the S protein in the virus. So just the protein, which is the bit that the immune system sees. So you're not putting the whole virus. These vaccines don't have the whole virus in people. So you
Okay.
can't get COVID-19 from the vaccine. Your immune system is just seeing the protein. And so the way that it works is that you get injected and then the mRNA goes into your
Hmm.
cells. And then in your cells, you have these small 3D printers that are called ribosomes. And they're like, their function is to sit in your body and to sit in your cells. And your cells will say to these 3D printers, make me this, make me that. Every time a
Okay.
gene is expressed, they'll say, can you make me, like, think of it like a chef, make me a burger, make me this, right? And the way that it does that is that it gives the 3D printer a recipe, which is what the mRNA is. It's just a recipe or a menu, not a menu, I guess it's a recipe that the
Okay.
3D printer reads and then uses to make the S protein of the virus. And then that S protein is moved to the surface of the cell so that your immune system can see it and start mounting responses to it. And so the one thing to remember here is that the vaccine is actually using a mechanism that the virus uses anyway, but it's safer because if with natural infection, again, your immune system would be bombarded by all these different parts of the actual
Yes.
virus. But with the vaccine, you're only showing the immune system the S protein. And then the last thing I'll say is that I know that some people have had some symptoms from getting the shot, especially the second shot of the vaccines.
Yeah.
And those symptoms, by the way, they should not last longer than 24 hours, and they do not. But the reason why is that I actually have a problem, and I think some immunologists have a problem with people calling them side effects because they're actually expected events. Because if you think back to what I was saying before, if you want the innate immune system or your immune system to be overwhelmed enough that it's going to activate those memory responses, then you're going to have
Yes.
some symptoms, right? So pain at injection site, a little bit of fatigue. And these are just symptoms that show you that the vaccine's actually working and working to
Okay.
make S protein that your immune system is seeing.
Thank you so much for that. That was an amazing explanation. Can we possibly know the long-term effects?
Of the vaccine, right?
Yes.
Yeah, so we don't know I think when people think long term, they think like they want 10 years worth of data. And we
Yeah.
don't have that, right? Because this was a brand new virus that emerged last January. But we do have a lot of historical data that shows that vaccines have extensive safety records, right? You don't get long-term adverse events. So I'll give you an example. The majority of any serious side effects that can arise from a vaccine will arise within a few hours or within the first few months of vaccination, right? And so that's why regulatory bodies will closely monitor vaccinated people in phase 1 for 8 weeks, because with past vaccinations, any adverse effects that were seen were presented within 6 weeks, because your immune system works faster than that, right? Like it sees something, it mounts a response. I know that with there have been reports of people allergic to one of the ingredients in the Moderna and the Pfizer vaccine. There's an ingredient called polyethylene glycol that is in everything, by the way. You have it in moisturizer and lotions. Like, this is something that if you had an allergy to, you would know by the time you're an adult. But there have been, I think, because this is kind of it's a statistical thing, right? The more people you vaccinate, the more likelihood it is that you'll start to see maybe adverse events in like some people. And so what we've seen is that out of 990,000 people vaccinated, 11 people present with an allergic reaction to PEG when they were vaccinated. But that allergic reaction is immediate. And that's why you're asked to sit at the doctor for 15 minutes or sometimes 30 minutes after vaccinating, just so they can monitor. And all of those people that had those reactions were treated with epinephrine and recovered. And so I think so I just wanted to mention that to say that any of these adverse events would present pretty much immediately, or at worst within 6 to 8 weeks of being vaccinated. And then the last thing that I just wanted to say is that mRNA is transient. So your ribosomes, these 3D printers, just take it in, make the S protein, and that's it. Like, it's not that the mRNA continuously keeps getting fed in. It's fed in, it makes the S protein. So it only has transient expression in your cells. And so while we don't have on this particular vaccine like 10 years worth of data, we know from like people who used this technology in 2017 that this technology does work the way we think it does. And also, vaccine trials are typically this short. And the next stage now is something called phase 4, which is after you authorize a vaccine, which is what most countries have done. The vaccine companies are then mandated to continue producing and reporting data and monitoring for another 2 years and reporting that data back. And so that's currently going on. And I will tell you that as of last week, 26 million Americans had COVID and 420,000 have died. However, 29 million have gotten the vaccine and we've seen 0 death. And so if you just look at those statistics, it just shows you that it's like a balancing of risk. And to me, it's a no-brainer. And I would say for like most people, it's a no-brainer in terms of risk assessment.
That was my next question, because you hear like a lot of people spreading information that people have died from the vaccine, and you're saying you haven't seen that then?
No, and I'll tell you where it's come from. I think there were 2 examples that come to mind. One was that, so what happens is that when you get vaccinated, and I'm going to speak a little bit to the US system as an example, is that after you get vaccinated, you're encouraged to continue reporting. I mean, in some people in the US, I haven't been vaccinated yet because I'm not eligible, but my friends that have been have said that you get text messages asking you, like after a couple of weeks, how are you feeling, etc. So that data is all being collected. So if you look at the US, they ask you these questions, and what you have is that in the US we have something called like vaccine adverse reporting. It's like a database that happens online, and anybody can go in and type in a symptom that they feel like was related to them vaccinating. And of course you have like a lot of trolly stuff in there. Like, you have people that are like, I vaccinated and then, I had a divorce, like things that, couldn't possibly be related. But what happens is that when all of those things go in, then like experts will go and look at those things and look at the actual risk that this was related to the vaccine, as opposed to it just being a random occurrence that just coincidentally happened at the same time. Because at this point, we're vaccinating millions of people, so things are going to happen coincidentally, right? And so in terms of whether people have died from the vaccine, there was everything as a headline, again, because these vaccines are being heavily scrutinized. There was a report that came out of Norway that said that 93 people that had been vaccinated in old people's home died after taking the vaccine. That immediately was a headline, as it should, to be honest, because people are afraid, and so like people should know. And then a week later, it was all a headline. A week later, the Norwegian government came out. I mean, my first thinking was, considering it was that many people, we've now vaccinated people in the US, millions of people, and we did not see that. The UK has vaccinated, other countries have vaccinated like a substantial percentage of their population and didn't see the same thing. So
Yeah.
in my head, I was like, maybe they all just got a random infection that just spread through around the same time. And actually,
Okay.
the Norwegian government came out a week later and said that they had established that those deaths had nothing to do with the vaccine and it was something else that had happened. But then, of course, like people were asking for retractions, but it's already a headline and people get worried.
Exactly.
That
Exactly.
was one example. And I think the other example was that there was a doctor in Florida that presented with something called idiopathic thrombocytopenia. It's a disease that can come on right after, but that has been associated before with vaccinating. And
Okay.
it's generally treatable. But in this case, this doctor developed symptoms of it and passed away, unfortunately. However, the timeline just doesn't quite fit because ITP usually presents around 3 to 5 days after vaccinating, and his symptoms presented a little bit longer. And so they are investigating it. But then again, I would assure people and say that this is one case that is still being investigated in like millions of people who have not reported the
Exactly.
same.
Brilliant, brilliant. I'm just gonna go try and do not a quick fire, but I'm gonna try and just read the questions that people
Yeah.
have submitted to me.
Yep.
So, is the vaccine going to be required every year?
We don't know yet because we're still monitoring memory responses. If you think we've had the first people who got infected with this was last January. So at this point, we have a year's worth of data. And so the answer to that is time will tell. But the suspicion from most immunologists is that given how coronaviruses as a family work,
Yes.
it may not be an annual thing. It may be an every few years thing. But there are some people that think that memory responses could last decades. And so I think that we will have that data in the next few months, but we just don't know yet.
Brilliant. If you take the vaccine, will we still need to keep getting tested for COVID?
So potentially, because what we're seeing now is an emergence of new variants. Because in countries that are completely not controlling the spread of this virus, you're hearing about the emergence. So we know that Brazil hasn't controlled it at all. We've got a Brazil
Yes.
variant, we've got a UK variant because the UK hasn't done a great job. And so again, the longer these viruses linger and have bodies to sit in, the more likely they are going to evolve into something that is going to change their behavior and make them worse, for example. And so at this point, the vaccines that we have seem to be protecting against the majority or conferring some level of protection to
Okay.
the variants that we have seen and we've discovered so far. However, there is a chance that if this virus continues to remain as uncontrolled as it is, that we'll get the emergence of new strains that will require new vaccines. And then as a result, if you've had the vaccine, it might no longer protect you, if that makes sense. So
That,
far, so good. But maybe
yeah.
one day we will, maybe one, like as these new variants emerge, if you have symptoms, you will need to get tested because obviously you're then mounting responses to a different variant and you should probably isolate to not infect more people.
Got you. So someone asked, what is causing the COVID to mutate, and is the vaccine likely to cause more mutations? No, that's fine.
So the vaccine is not likely to cause more mutations because what vaccines do is that they have your immune system ready to fight the virus as soon as you're infected with it, right? So they're putting
Yeah.
pressure on the virus and not letting it like hang around and lounge around in cells and like infect new cells. So actually, if you look at previous viruses and how we've managed to mitigate them, vaccines were very, very effective at like
Mhm.
preventing the spread. And also like so far the trials have shown that they do prevent disease, but I will tell you that the suspicion is that they are going to have a significant impact on the spread as well, given that
Okay.
they give your immune system time to like put pressure and clear the virus.
Brilliant. So essentially, what we're saying, the measures are in place to stop overwhelming health services and stop the virus spreading, basically, and possibly mutating.
Exactly. And preventing the emergence of new mutations. Exactly.
Thank you. Someone said, I've recently started taking vitamin D. Does this offer any protection against COVID?
So the vitamin D question is it's a little tricky because vitamin D in general, it's something that deficiency is something that you get typically with inflammation. And
Yeah.
so not in all diseases where you see vitamin D deficiency does supplementing with vitamin D actually have any effect, right? Because
Mm.
it's kind of which came first, the chicken or the egg. And with vitamin D, sometimes it's the chicken, sometimes it's the egg. It just depends on the disease. However, what we do know with COVID-19 is that older adults, nursing home residents, Black, Asian, and like minority ethnic populations, these are the same groups that have been disproportionately impacted by COVID-19 and are also the same groups that have been noted to have more enhanced vitamin D deficiency, right?
Yeah.
And so the rationale is if you're supplementing, maybe it could do something. And so there just isn't enough data right now to say that taking vitamin D absolutely does prevent you from being infected with the virus. We do not have any data for that. The only thing that prevents the virus is a vaccine, right? Because you've seen it before. However, it is low risk. And if you are vitamin D deficient, there is no harm in taking it because we do have some in vitro, so like lab data, not in humans, showing that
Okay.
vitamin D could be great for regulating your immune system. So I would say if you recently started taking it, continue to take it. But in terms of it offering protection against you getting COVID, the only thing that can do that is you having seen it before.
Brilliant. Thank you. Are meat eaters more likely to die from COVID compared to vegans?
No, we have not seen. I think this is another reason why there's been panic around this virus and this disease is because it is unpredictable, and you have people who you would perceive to be really healthy that are on plant-based diets and are athletes that still got really sick and didn't do well, and in
Yes.
some cases passed away. But you also have people that you might not perceive to be healthy who recovered from the disease, and so that unpredictability has been kind of the key reason why we've been a bit panicky. So no, there's no data to show that meat eaters are more likely, but I do know that there are some research labs that are looking into like the impact of diet a little bit more.
Brilliant. And there's final three, sorry. Someone said, I heard they're putting enzymes in the vaccine to change our DNA in some kind of gene reconstruction therapy. Does that question even make sense?
Kind of. The answer is no, they're not doing that, but I'll tell you what that rumor is related to. It's because
Okay.
when people hear messenger RNA, they hear DNA, and
Yes.
DNA is being meddled with. But I would two things to respond to that. One, a basic tenet of biology is that it's DNA to RNA to protein. It doesn't go backwards, right?
Okay.
So you use the DNA to make RNA, which is then used by your ribosomes to make the actual protein. Okay. And
Okay.
so we've tried to make it go backwards, and we can make it go backwards in the lab, but you can't make it go backwards in the human body. And so
Oh.
injecting mRNA into somebody isn't going to suddenly go in and meddle with your DNA because it can't go backwards, right? But
Mhm.
but the main reason why this isn't necessarily a valid argument is because not only can our bodies not make the enzyme that allows us to go backwards, but we've tried, because obviously with genetic disorders we've tried in the past to work out how that you can like knock out genes.
Oh.
So if we could
Okay.
do that, trust me, we would have done that, and we can't do that. But the main reason why there's no worry about the mRNA changing your DNA at all, or this being gene therapy, is because your DNA is in your nucleus. It's locked away in the lockbox. mRNA doesn't get into the nucleus. It's outside with the in the, like with the 3D printers, with the ribosomes. And so all to say that mRNA doesn't get into the nucleus. It's not getting in near your DNA. But even if we were to force it to try to get there, we don't even make the enzyme to allow the mRNA to go backwards to meddle with the DNA. So the answer to that is no.
Thank you. And final two, people are saying that the community, scientific community has come up with a vaccine just to make money.
Yeah. I mean, typically, pharmaceutical companies don't make money from vaccines because they're compared to other treatments, because
Okay.
they're a one shot, right? And so you have the one shot. But I think also, I will tell you that in relation to COVID-19 in particular, they're not. They are doing this because of the payout of it, right? As in, if the fact that they have managed to work really hard, work as much as they can to get these vaccines authorized, and vaccines that are safe and vaccines
Hmm.
that work, the fact that they have managed to do that means that they people will start to build trust around them, right? Like
Hmm.
if this vaccine rolls out, and more people start to get it, then people are going to start to associate names like Moderna, Pfizer with like, these are the people whose science is so phenomenal that
Oh,
they managed
okay,
to funnel.
okay,
So
okay.
vaccine companies, but you've got to think of the fact that it's very easy for an adverse event to happen, and for it to actually destroy the reputation of these companies, for people to say, oh no, someone died from the Pfizer, I do not want to take it anymore, I'm going to take this other one, right?
Okay,
And so
yes.
so keeping in mind that yeah, I completely understand the distrust around pharma companies, but they're not making as much money as people would imagine from these vaccines. And also what I mentioned, which is that what happened was that Merck was a player in the game, and Merck also had a vaccine that they were developing for SARS-CoV-2. But when they
Yeah.
rolled it out into their clinical trials, it wasn't working. It didn't cause harm, it just wasn't working in people. They weren't seeing antibody responses being mounted in people. And so actually they retracted their vaccine. They said
Oh
that they've
wow.
stopped because they don't have a vaccine that works. And in fact, Merck has announced that they're going to help the other vaccine companies to manufacture and scale up theirs in order to get as many out as possible, because obviously their manufacturing was ready and set up for theirs, but they decided to cancel theirs. So it just shows you how much scrutiny these companies are under, and that they're not invested. Like, it would be a long-term bad strategy for them to like be
Exactly.
shady here, but also they can't really be shady because they're not the ones analyzing the data. Like, when they run their clinical trials, and then when they
Yes.
they say, great, people have antibodies, we've looked at people, they have antibodies, we've looked at people, they're not getting sick. They're not just saying to these regulatory bodies, trust us, people aren't getting sick. They're showing them the data, and then these regulatory bodies are responsible for taking weeks to look through all of the data to make sure that everything that they've done is valid. And these people that analyze the data, they also involve other boards. So things in the US, we have something called the Data Safety Monitoring Board, the DSMB,
Okay.
which is an independent agency which will analyze that data. So just to make sure that like one person hasn't just gone in and gone mad, right? Like, too many people
Yes.
have their eyes on this and on the raw data for that to happen.
Got you. And how can we improve public trust in scientific literacy?
Oh, I was going to say, it's when you work it out. Let me know if you have any tips for me,
I
because
mean,
you're
I
the
hope this podcast is some way of doing that. I
yeah.
really do hope so. I really do hope so.
Yeah.
It's
So in seriousness, I think that it's okay for people to ask questions, right? People have a right to ask questions. Like,
yeah.
you're putting something in your body, you don't have to blindly trust. Talk to as many people as possible and come to a conclusion. But I think in terms of improving public trust and scientific literacy, I think there needs to be more conversation. And I think that the scientific community has realized what a poor job it's done in terms of
Mhm.
communicating like the way that trials are run with other diseases or with other drugs, or like how we analyze data, how competitive the field is. Like, if you tried to like come out with a crazy hypothesis, like how much you'll put through to actually prove that. And I think that because science has always kind of been in ivory towers, right? And
Yes.
thought, people like, I'm a professor, like if someone wants to read something, they can read it, or I'm going to explain it, and I'm going to use a lot of jargon because this is really complicated. But what
Yes.
we've point now where people prefer the simple but safe answer over the
Yes.
slightly complicated but like hard
Mm.
answer. And I think that people have to remember that while it's important to ask questions and try to understand as much as you can, not everybody is going to be able to understand some of these really complicated topics, but it's okay
Exactly.
to invest some time researching them and the process. But just make sure again that you speak to as many people as possible, and not just to like rely on one person who like has sent a meme. Make sure, like, a couple of tips that I can give is just always Google who wrote the source. If someone sends you a meme or an article or something, just plug the author into like Google, see who they are.
Okay.
Are these people who have researched this viruses or disease, or are they MDs? Have they worked with people with this disease, or are they someone in an unrelated field who might be as confused as anybody else, right? Is this somebody who spent and has invested a substantial amount of time to gather expertise and is able to like provide context? I also think it's important to read sources that actually have references in them. So if somebody
Okay.
sends you information, ask them where they got it from. I think that should be normalized, particularly with WhatsApp, where
Yes.
we've all suffered with
All our
the
aunties.
we've all suffered we've suffered with the forwarded many times. Like, it's a pain. And I think that it's important to ask, like, where did you get this information from? And to help kind of get an idea if somebody like if some information has just been made up by somebody. But also keep in mind that the author might have some potential objectivity, and look for like any disclaimers. Like, sometimes the authors will write, disclaimer, I own a company that works on, you know what I mean? And you can tell that,
Okay.
okay,
Yes.
this person is incentivized. So yeah, like, I
Okay.
think that it's just talking to as many people as possible, and maybe some of those tips can help.
Thank you so much. And finally, when the zombie apocalypse starts, where are you going to be?
I don't know. I'm going to be praying to God somewhere. Like, just, I don't know. I'm going to be honest. That's how it feels right now with people not taking like the measures in like seriously. When you get messages
Yeah.
saying, "Hey, do you want to hang out?" and you're just like, "I just want to hide," and you know, pray these people away. No, I'm joking.
Thank you so, so much. This has been a super, super insightful. I hope you guys listening out there have found it as insightful and interesting. And I have. I will post Dr. Azza's in socials in the description of this episode. Please, guys, like, comment, subscribe. You're listening to the Malcolm Effect with Mamadou. Be that on YouTube, Spotify, or Apple Podcasts. Until next time, take care, guys.
Thank you.